What's up guys, it's Tech Stevens here. I'm going to run through how to make your code base nicer in TypeScript, going a bit further with typing. So one of my biggest pet hate on a big code base is seeing things defined as string everywhere. String's so common, it's going to be used. It's a valid property type and you need to use it, but it doesn't help with the compiler, it doesn't help on certain things, and it doesn't help the developer either. Let's look at this for example. I've mocked up a pet hate kind of classes and stuff like that. So you can see here, everything returns a string. We've got user account string, order ID string, user account item ID, order ID. You know, these are all valid types, but it doesn't help when a developer makes a little mistake like this, and then the compiler will still compile and say, fantastic, everything's fine. But it's not, obviously, because amend order wanted a user account ID and an order ID. And if they're strings, that's going to hit the API. You're going to have to debug the issues all the time, and it gets confusing. You imagine this times 50, and it is just very, very confusing. But we can make this a lot nicer. And I'm going to show you how. So firstly, let's create a base type. So in here, we're going to have standard logic. We're going to have abstract logic that's going to validate certain classes that extend this. So export default abstract class base type. Now it's going to take some generics of a T class, which is the class that extends it, a T value, the raw value. In that case I was talking, it would always be a string, and T set value. If you want to take in a number instead of a string and transform it, you want to take in lowercase and transform it to uppercase, that is going to be the set value that's passed into the constructor. So at the top, we're going to set a private value, which is going to hold our raw value in the base class. And in our constructor, we're going to take in a value of tset. Perfect. Now we're going to need a few methods in here. Firstly, we're going to need a getter, a public getter for the raw value. So it's on the public interface and people can get to it. So if this dot value isn't defined, if it's not defined, we want to throw because something's gone wrong. We're going to throw a new error. Value not found. Perfect. And if not, we're just going to return the value. Return this dot value. Perfect. So we've got our getter. Great. We're also going to need some of the things. So, for example, you might want to compare one of these new nice type classes together, and you can do this with creating an equals, which has a type of your base type itself, and which returns a boolean. And what you then can do is return other dot the getter value equals this dot the private value, and you're going to be able to do complete equals without having to get to the raw do this every single time. So you can just do dot equals, which we'll show you later. We also need a set value. So we made equals public on the interface so anyone can get to it again. So protected, we only want this to be able to be seen on the class that inherits it. So set value will take a T set value and it will return a void. And what it will do is this dot set our private value equals, we're going to have to cast this to unknown. So we've got our set value. We're going to also say, we're also going to set a abstract validate. This base class can't know too much about the validation. Validation will be different for each class that inherits this. If it's a GUID, for example, it will have different validation. If it's user account ID, it will have different validation. So we're basically saying when you inherit it, you have to write your own validate method or it will not compile. Great. So we've got those key methods in the constructor now. We're going to need to say when this constructor is called, we're going to set the value, and then we're going to call validate on the class that inherited it. and to do all the validations straight away as soon as you create a new instance of it. So that is that part. We will then create, let's start with a user account ID. So we're going to create a user account ID proper type. So we're going to export default class user account ID. It's going to extend the base type we've done. It's going to take a user account ID, and it's also going to take a string, and it's going to take a tset value of string or number. But what I seem to do, because we have to repeat that tset quite a lot, is at the top I normally create a tset value, and I just put that here, so we don't have to keep changing it, and it can only be changed in one place. We then create a constructor which takes a tset value, and it will call our superclass with that value. Perfect. Now, as I said before, it's going to say, hey, you haven't created the validate method, which is fine. We haven't done that. So we're going to go and do that. And what this gives you straight away is this will not compile. It will tell you the same error until you do that. So when other developers are creating these types, these more complex types from the base type, the compiler will tell them that they need to make sure that they write the validation logic. So we're going to make this protected because we don't want it to be exposed to the public. And what we're going to say is we're going to go, right, if it's a type of, use the getter to get back to it, if it doesn't equal a string, or we're going to say if it doesn't equal a length, just to show you examples, mark it not equal 5, then we will throw a new runtime error which says user string supplied is not a valid user account ID. Great, so your tests and stuff like that will catch all of that stuff. We're also, what I said before, is on the base class we've got a default set value, but if you want to transform that and stuff like that, for example, this takes a number and we want to transform that to a string all the time. We want to do that. You can obviously go to as much logic as you want here, but for this example, I'm just going to show you that. So we're going to override the set value logic. I'll type t set value void, and we're going to say on super, on the base class, we're going to pass in value, and we're going to pass in a toString here as well. Now, that's great. You might say, okay, Josh, so I'm going to create a new instance of this. How I'm going to have to try catch this all the time. So this is where I make another nice little method. So I tend to create this in a nice utils class, and I tend to create again a default class utils, and I always create a static try pass. This is going to be a generic one. It takes t, so I don't have to write this for every single one I create. We'll create a type, which will be a new instance of, and it will take an any result because it's going to have to always do it. Oops, got that wrong. It's going to take in a result, and it's going to be anything because our classes that inherit the base class can take what they want, and then it's going to create an instance of t all the time. And our value, again, is going to be any, because we're not going to know that. And I kind of like to create a nice typed response here. So if passed is false, then we're always going to get an error back of error. Or passed true, then we're always going to get a result back of our t instance. Pretty, you can make that beautiful for me. So instead of you having to try pass it all the time, I'm going to try pass it in this utils class. So we're going to get our passed value, and we're going to be able to do if our new type We're going to pass in the value. So we're going to say it can take any result, and here's our value. And we're going to return, if it doesn't throw there, past true, and result equals past value. Probably, let's just call it instance. I'm a big sucker for nice naming, so might as well do that. We get a catch at this point, we catch the error, and we can then just return our other object of false with our error. Oh, do like that, that comma, right? So we got a nice little generic try pass here. And then I always then make a static property on the class itself, which can take in the tset value of our generics. We will we can create this pass stuff again. You'd probably want to create this somewhere so you can reuse this interface. For me now, I'm just going to do it on the fly so I can get my point across. As you see here, comma, pass, true, and then we're going to get our result. And because we know the result should always be a user account ID, we can do that. And it's as simple as them doing return utils dot try pass, and we pass in our user account ID, and we pass in the value. That will then return as an instance of past and the result if we want to. So perfect, we've got a dynamic user account ID. So how is this going to straight away hook in to our example? So where are we? We're in here. So now this can take a user account ID. It returns a user account ID. Mock response is now a instance of a user account ID. User account ID here. Amend order, user account ID here. This will need to be like that. Take the example. And then as you see, oh, we got it the wrong way round, even in my example before. So at this point, we now can go, this get user account ID should return a user account ID now. So we've got a proper, strongly typed user account ID. Amend needs to take a user account ID as well. So we put that here. And order ID needs to take in a user account ID as well. And see, it's everywhere. And then user account value. Great. So you TSC this. You've got your typed value. You've got your example. If I run this, dist.example.type, maximum call stack. Not what I expected, and I don't know why. Simple mistake to make. It's going to call itself all the time. We will make mistakes. Voila. So we have, it's rendered all the stuff for us exactly how it did before, but we're starting to get a user account ID now. We're starting to get nice typings in our stuff. So next, let's look at the order ID and item ID. And we're going to say, and we're going to assume both of them are GUIDs. So I'm going to show you how you can even go even further with this and also inherit classes that extend the base class, and then you create something else that extends that. So for example, we're going to create a GUID type here. And then we're going to also create an order ID type that inherits the GUID type. So go and create a GUID. That should live in the source. My bad. And we're going to do the same stuff as we did before. GUID extends base type GUID string or undefined. I'm going to do what I did before. Type t set value equals string or undefined. We're going to have our constructor, obviously, which is going to take a value. Now, it's a little bit different here. I want the GUID to create a new instance of a GUID if no value is supplied. If I do something like this, for example, let me compile this just to show you. So new GUID. I'll have to pass in an undefined, which I don't want to have to do. I want to be able to do new GUID like that. So I'm going to do that instead, which would allow me to be able to go like that, and if it's like that, create a new instance, create a new GUID. So we're going to do, it's going to obviously warn us that we need to do validate, which is understandable. So we're going to write our own validate for GUID again, and we're going to go if type of this dot value not equal string, and we're also going to paste in a few GUID methods which will generate GUIDs and check stuff for us. I'm not going to go and type that regular expression out in here. Again, all of this can be found if you're following along on my GitHub. So just pause the video and put that in. So if it's a string and it's not a GUID, if it's a string or not a GUID, string supplied is not a GUID string. Great. There's our validate. And we're going to overrule as well the set value, because as I said, we want to be able to create a new instance if value is not supplied. Set value will take a value or undefined. If the value itself is undefined, super.set value this dot create a new GUID of the little method that I pasted in here, else super dot set value the known GUID passed in. We're going to also create our try pass of value t set value. It's going to return past. I'm just going to copy the one that I had before, and then return utils.trypass.GUID.value. So we've got all of that now. Great. We can create a new GUID. For example, console.log. I'm just going to put a watch on here, so I don't have to keep doing TSC, console.log, new GUID. As you see, it allows me to take that. We'll go back. And we'll run node examples. You see it's generated a new GUID. It will generate a new GUID again. It will generate a new GUID. But it will also accept a well-known one and bring that back for us as well. So we've got our GUID, we've got something generic, again, we can reuse. So if we go back to our example, we've got order ID, item ID, then they're all strings, but they're going to end up being GUIDs then. So let's go back to the source and let's create a order ID type. And this is going to be dead simple. We're going to be able to go order ID, and it just extends the GUID. And it's as simple as that, really, if you want to create a order ID. So if we go back to here, damn you. You see, it's creating an order ID here for us, and also it will also create a new GUID for us here. Now, what this also allows us to do is be more strict with an order ID. Let's say order IDs always start with a 9-2. We can then overrule the validate method again on the order ID, but keep all the other logic that exists of the GUID stuff that we've created. Now, we'll do if type of this dot value not equal string, or this dot, and we can do is GUID because we made that protected on the GUID class itself, so we're reusing code again. So if it's not a GUID, or if the first 2 digits of it are not equal to 92, then we want to throw a new error of order ID is not valid. Okay, perfect. So we go back to this and we will go paste this thing in, for example. We'll get an error and it will tell me the order ID is invalid. But just for this sake, if I change that to a 9-2, it passes it and it's absolutely fine. So it will be able to show you nice runtime errors, as well as getting a lot more visibility on compile time errors. So if I then go back to my example here, where's our order IDs? So this will take a proper order ID. Amend will take a order ID. This will return an order ID. And then this will also return an order ID. As you see here, now it's going to complain. So we can create a new order ID here, which is going to start with 9-2. We'll also create a new order ID here that starts with 9. Oh no, is it? Yeah. That needs to be order ID as well. And that. Great. Sorry, it's loads of face. This is my little example. So that should now compile. Order ID, order ID, order ID. Great. So what we also get here now is if I just make a well-known order ID. Just so I don't have to keep doing that. So what this also does now is if I put user account ID there and well-known order ID there, the compiler is going to actually tell me it's completely wrong. So we're getting to a point now where we've got very strongly typed services. And I'll explain the last bit of stuff that I do within the API service once I have created the last one, which is item ID, I think. So let's undo that and go back to here. Let's create a item ID type. And this is just going to extend. Good. That's all it's going to do. We're not going to set any rules here. It's just going to be a valid GUID. Go back to here to do the last few bits and bobs. Item ID. Item ID. It's going to throw here because this isn't an item ID. Okay, so we've got all the item IDs compiling in proper typings. And voila, it's back to exactly how I would want it to be. User services itself only ever know about proper typings. Our order services, again, only ever know about proper typings. Now, our API layer is the layer that I would transform this over the wire. In Angular, there's something called HTTP interceptors. If you're using Angular, you should be looking into them. They are really, really, really good. They will transform stuff over the wire for you. What I tend to do in the user in API services is just before it does the request, transform that back to a string, and then when you get the response back, transform that back to a user account ID. So for example here, let's make this return a string now in the response, and then here I would cast it back to a user account ID itself, which is fantastic. Or we can do something which I didn't show you how to write the code for, of user account ID dot try pass, which will take in a response, and then we can do if passed response parent passed. Let's call that result. There's nothing worse than pass.passed, eh? If passed equals true, your result is going to give you there's nothing reserved then. Result.result. What the hell can I call this? Developer one-on-one issues, naming stuff. So user account passed. Let's call it that. As you see, the result is a user account ID. So you could just then return it in here. Else, if not, it's already got a return. You throw new error. API did not return proper user account ID type. Voila. So you do that. It's all compiled still. If this was 1, 2, 3, 4, 5, 6, for example, throws an error. API did not return the proper user account type. And if I do the same on order API service, one thing that we will need to do is, at the moment, if I go and change this, I'll copy this part, like that, order ID passed, order ID try pass, response dot order ID string passed result. Now it's going to tell me that GUID is going to return GUID because this try pass is not been written in our order ID class. It's still using the inherited GUID one. So we'll need to go to our order ID and we'll need to quickly write a public static try pass value string undefined, which will take in a pass value, turn an order ID, and we just do what we did before, utils.try pass, taking order ID and a value. Perfect. So now all our compile errors have gone away and we can run it as we did before. But our API service is handling our stuff going over the wire in our mock. As you see, we're passing a string all the time, and also coming back in our API service, we're getting back a string from the API and we're turning that back into an order ID, a proper typed order ID. This makes coding a lot nicer. If you look at the before and after and you look at your compiler and you're using TypeScript to the full extreme, I would highly recommend going through your big libraries that you've got and making proper types. It's as easy as a base type and then once you've started doing your base types and you start writing your types, you know, some things would just look like that. Look how easy the item ID looks. Yes, you would need your try pass in there if you want to do it, but there's no hard rule that you have to do a try pass. It's going to throw an error anyway. So even if you just did new order ID, response.order ID, that will work as well. And you could just return it here. It's just showing you both ways that you can do it. So yeah, that is my tutorial on how to create awesome types. If you liked it, guys, please do like, please do subscribe, please do comment. I'm going to be doing weekly videos on all things TypeScript, .NET Core, Git. This is my first video, and hopefully more to come. So thanks for your time, guys. Goodbye.